A new photo from NASA shows the International Space Station photobombing Tuesday night's supermoon, just hours before the rare super blue blood moon. NASA tweeted the picture and wrote, "A lunar photobomb." The space station and its 6 passengers pass in front of the full moon last night in this incredible NASA image. The space station was traveling at about 5 miles a second. The lunar trifecta in the early hours of the following morning had not been seen by much of the world for more than 150 years, but was caught in spectacular photos gracing the world's skies earlier this week. A super blue blood moon is the result of a blue moon, the second full moon in a calendar month, occurring at the same time as a supermoon, when the moon is at perigee and about 14% brighter than usual. It also combines with a blood moon, the moment during a lunar eclipse when the moon, which is in the Earth's shadow, takes on a reddish hue. While people in the Eastern Hemisphere saw their last blue moon total lunar eclipse in 1982, for the Western Hemisphere, the eclipse was the first blue moon total eclipse since 1866. "It's an astronomical trifecta," said Kelly Beatty, a senior editor at Sky and Telescope magazine. "That red light you see is sunlight that is skimmed and bent through Earth's atmosphere and continued on through space to the moon," said MacRobert of Sky and Telescope magazine. In other words, it's from all the sunrises and sunsets that ring the world at the moment. While much of the world has experienced a super blue blood moon, the moon above the UK was just a super blue moon. This occurs when a blue moon occurs at the same time as a supermoon, but without also combining with a blood moon. Despite the UK not experiencing a lunar eclipse and therefore missing out on a blood moon, many pictures seem to show the satellite glowing red. Dr. Daniel Brown, an astronomer at Nottingham Trent University, told Mail Online this is because, when the moon is quite low in the horizon, for instance when it is rising or sinking past the horizon, the atmosphere of the Earth will redden it independent of an eclipse. A lunar eclipse occurs when the sun is on the other side of the Earth, while the moon is located on Earth's opposite side. Most of the time the full moon sits above or below Earth's shadow, and the moon remains flooded with sunlight, explains Dr. Tanya Hill, an honorary fellow of the University of Melbourne, writing for The Conversation. But twice a year, the 3 bodies fall into line, so that Earth casts its shadow on the moon. The Earth's shadow is not completely black, but has a reddishy hue, which has led many cultures to describe it as a blood moon. Sunlight manages to reach the moon, but first it has to pass through Earth's atmosphere. This makes the sky redder, as it scatters away shorter wavelengths of light, and also bends the path of the light, directing it into the shadow. Unlike a solar eclipse, this lunar eclipse can be safely viewed without protective eyewear. We've had a lot of supermoons and we've had lunar eclipses, but it's rare that it also happens to be a blue moon," said Jason Oftenberg, Associate Professor of Physics and Astronomy at Embry-Riddle Aeronautical University's campus in Daytona Beach, Florida. "All three of these cycles lining up is what makes this unusual," he added. "It's just a wonder to behold." The first supermoon of this year appeared on 1 January. Lunar eclipses during a supermoon happen rather regularly, and the last one was in September 2015. Lunar eclipses occur at least twice a year, while supermoons can happen 4 to 6 times a year. The next supermoon lunar eclipse visible throughout all of the United States will be January 21, 2019, though that one will not be a blue moon. A full moon occurs every 29.5 days, but our months are longer, excluding February. This mismatch of timing means that every couple of years there comes a month with 2 full moons. According to experts from NASA, the event will also offer experts a chance to see what happens to the moon when it cools quickly. This information will help them understand characteristics of the regolith, the mixture of soil and loose rocks on the surface, and how it changes over time. The whole character of the moon changes when we observe with a thermal camera during an eclipse, said Paul Hain of the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder. In the dark, many familiar craters and other features can't be seen, and the normally nondescript areas around some craters start to glow because the rocks there are still warm. Normally, the transitions into and out of darkness and the temperature changes that go with them are spread over the course of a lunar day, 29.5 days. During a lunar eclipse, the temperature swing is so dramatic that it's as if the surface of the moon goes from being in an oven to being in a freezer in just a few hours, said Noah Petro, Deputy Project Scientist for NASA's Lunar Reconnaissance Orbiter, or LRO, at Goddard Space Flight Center in Greenbelt, Maryland. From the Haleakala Observatory on the island of Maui in Hawaii, the team will conduct their investigations at invisible wavelengths where heat is sensed. They've done this kind of study a few times already, singling out individual lunar locations to see how well they retain warmth throughout the eclipse. How quickly or slowly the surface loses heat depends on the sizes of the rocks and the characteristics of the material, including its composition, how porous it is, and how fluffy it is. By comparing the two types of observations, the team is able to look at variations in particular areas, say, the lunar swirls at Reiner Gamma, or an impact crater and the loose debris around it.